Hello everyone, my name is Deng Jianhua. Today, I will use the PPT to show you my paper. The title of my paper is Research on Optimal MPPT of Photovoltaic System based on Disturbance Observation Method. My report can be divided into the following four parts. The first part is the main content of the paper, and the second one is the realization principle of this method, and the third one is the main advantages of this method. Then the fourth is construction of the entire photovoltaic system. Now, let's look at the first part. The first part mainly introduces the main content of the paper. The picture above is the equivalent circuit of the photovoltaic cell. Based on this equivalent circuit, build its mathematical model in Simulink. The formula for establishing the mathematical model is as follows. Note 4. According to the previous conditions, the equivalent substitution can be obtained on this. The picture is the mathematical model of photovoltaic cells in Simulink. We can get the output curve of the photovoltaic cell through simulation operations. The image shows that the output power of the photovoltaic cell changes with the voltage under certain external conditions. The photovoltaic cell has the maximum output power. Now, let's look at the traditional power tracking method of photovoltaic systems. Traditional methods mainly include three. The first one is the constant voltage method, and the second one is perturbation observation. Then the third one is incremental conductance method. Due to the poor stability of the photovoltaic system, it is necessary to develop a high-efficient MPPT method. Then we look at the second part. The second part mainly introduces the realization principle of this method. This is the model of the traditional perturbation observation method. This method is relatively simple and convenient in practical applications, but the effect is not very satisfactory. The P-E relationship picture of the photovoltaic cell can be obtained by calculation as shown in the picture. So, any point in the figure above indicates that the set of heat at a certain moment is dk, and then two equidistant points are taken before and after this point. They are dk minus 1, dk at 1, and dk at 1 is equal to dk at delta d. dk minus 1 is equal to dk minus delta d. And finally, 9 different situations of 3-point parts can be obtained according to the different positional relationships. First, set the reference quantities H and Y. When pk is bigger than pk minus 1, y is equal to 1. Otherwise, y is equal to minus 1. When pk at 1 is bigger than pk, then y is equal to 1. Otherwise, y is equal to minus 1. When pk is equal to pk minus 1, pk at 1 is equal to pk, then y is equal to 0. H is equal to y1 at y2. The MPPT control process introduced in this article is as follows. If pk is bigger than pk minus 1, pk at 1 is bigger than pk, then h is equal to 2. If pk is bigger than pk minus 1, pk at 1 is smaller than pk, then h is equal to 0. If pk is smaller than pk minus 1, pk at 1 is smaller than pk, then h is equal to minus 2. If pk is bigger than pk minus 1, pk at 1 is equal to pk, then h is equal to 1. If pk is equal to pk minus 1, pk at 1 is smaller than pk, then h is equal to minus 1. If pk is equal to pk at 1, pk minus 1 is equal to pk, then h is equal to 0. Now, I will introduce the new MPPT method. This control method of changing the duty cycle based on the disturbance observation method can significantly reduce the oscillation of the output pole of the photovoltaic cell at the maximum power point. The duty cycle is simple and the relationship between the pole is compared and then an appropriate duty cycle with output. Finally, the output duty cycle is PID adjusted and the final duty cycle is output the switching element in both circuits. The photovoltaic cell can output the maximum power, so that the cell always works near the maximum power point to achieve the purpose of taking the maximum common power. It is the P and U characteristic curve diagram of the output of the photovoltaic cell when the temperature is changed. The image shows that the output power of the photovoltaic cell changes with the voltage. Under certain external conditions, the photovoltaic cell has a maximum output power. It can be seen from picture that when the temperature of the photovoltaic cell is constant, the net intensity increases. The short circuit current of the photovoltaic cell will increase with increase of the light intensity. The output power of the photovoltaic cell will increase with the increase of the light intensity, and the maximum output power also increases with the increase of light intensity. It is worth mentioning that their changes are very obvious. Therefore, we can get a conclusion. That is the power voltage relationship and the current voltage relationship of the photovoltaic cell is not a linear relationship, but an obvious non-linear relationship. At the same time, we can also get that the short circuit current and output power of photovoltaic cells are greatly affected by the light intensity, and the open circuit voltage is relatively small. According to the boost circuit, the input in Yanpin are therefore only the duty cycle needs to be adjusted so that the input impedance of the photovoltaic cell is equal to the load impedance and the maximum power can be obtained. Improve checking efficiency. Now we see part 3. The effect of this method has 4. The first one is faster tracking, and the second one is smaller oscillation at maximum power, and the third one is easy to implement, and the fourth is easy to use. From the above picture, we can know that the improved power tracking method has better results than the traditional method, and has certain reference value and particle value. Now we see part 4. It is construction of the entire photovoltaic system. This is the simulation model of the entire photovoltaic system. At the present, there are many methods for maximum power tracking of photovoltaic system. The traditional method can no longer meet people's requirements due to their imperfect tracking efficiency and tracking accuracy. Therefore, the article proposed can improve the disturbance observation method, and the feasibility of the method is verified through simulation experiments. This method involves the program of photovoltaic cells oscillating at the maximum power point, reduce power loss, and increase the efficiency of the power tracking. For the power tracking research of photovoltaic system, a certain reference price. Thanks for your time.